Stream connected, that's good. YouTube. Without chat. YouTube's connected. That's good. My Window's not working. Okay, time to send the final 2 messages. And paste. And post. Okay. New tab to get rid of that. Hello, chat. Feels weird listening to the main menu music while not playing. Anyway, oops. So title suggests, and description and whatever. Today we're going to be making games, because I've worked out how to make games. We can actually do something other than farming, what we started on last week of repair. In the meantime though, well, correction. Before we work on games, I'd like to get mazes automated, and a maze is a game in a way. If we just spawn in a maze, it's kind of a game. It's automated though, so not as fun. Yes, I would like to get mazes done. Now, I've done a maze before for Advent of Code, but that was a while ago, and I don't feel like getting that code back. Nope, I can't. Why? What? You can, you can, I do not think you could farm inside of a maze. Okay, let me just quickly complete this maze. No, no. We're getting button locations. Okay, now polyculture. We can at least get that going whilst we wait. Well, whilst we work on the maze algorithm. So, as for the maze algorithm, I think what I want to do is simple maze algorithm, nothing too complex. I don't know many complex ones anyway. So, time for the maze over. Dev solve maze. And we'll have a maze map. Yes, of a dictionary. So, in order for mazes, we have a... Oh, there is a can move. Okay. So, what we will do is we'll stick with the rule of follow the left rule. And because following the left rule is always easy. The that's probably going to break at some point. But by that point, we'll have a basic maze. So this will be the first loop. And then... Yes. I know it's only been a week, but it's going to take me a moment to remember what to do. Get pause. Did we create a function up here? No, okay. New function. Actually, a new function. We will add it into here. Def position. Return get pos x, get pos y. And back to polyculture. Okay, move import position. This is going to help us. Equals. Yes, we want another dictionary. Can move. How does can move work again? Can move north. Okay. And dictionaries, can be taken a string key? Hopefully. Can move north. East. Can move east. West. Can move west. And south. Can move south. So that solves the first thing. If get ground type, not ground is entity type. Treasure, mazes. Get entity type, yes. Get entity type equals entities.treasure. We have found the treasure we need to return. Else, we store where we can go. We also have we also have facing direction equals north. It's easiest. Then if can move north, if can move facing direction, so maze first. Don't need semicolons, I've just been writing TypeScript for the past weeks. I'm used to the language syntax. And more code into here for fern. Rotate code because I don't think we have that anywhere else. Yeah, nope. Def rotate clockwise direction. If direction is north, return east. If direction is east, return south. Direction is south, return west. If direction is west, return north. Def rotate counterclockwise. Copy, paste. And just change these to west. North to west. West to south. South to east, east to north. East. It's not coming through on stream. There's background birds. Huh? Okay. I thought background birds would have come through, but apparently not. Anyway, that's for another time. Back to polyculture. Not that one, this file. If we can move this facing direction, we solve maze first. Otherwise, we rotate left, which is counterclockwise. Facing direction equals rotate counterclockwise facing direction. So needs first. And yeah, we can do this in here. Move facing direction. So this should hopefully make a map of the maze for us to later process. Yeah, let's just test if this works. Main. Solve maze first. I'm not going to worry about the map, I just want to know if it works. Generate maze and solve it, which work. I need to global it. Okay. It's not counterclockwise, it's clockwise. No, it's not clockwise either. Okay, what did I do wrong? When this here is facing east. Yes, but when is this going back and forth? Because apparently I can't work out rotation. Then counterclockwise, counterclockwise, counterclockwise. Turning left is harder than it looks. I don't know about that skill. I know the skill I'll be referencing, I just don't know why. Oh, We have a new hat. Where's the hats? Hats.traffic cone stack. Fat hat can wait. I need to work out how to do the maze. It's traversing the maze, which is the hard bit. Because according to the drone, all the directions are the same. Even though we're facing a different way, still north or east. So, if we switch back to counterclockwise, prioritize is going forward first. Okay, let's see what this is. Probably going to break. Rotate clockwise. It got stuck. Because I put the line in one order. Oops. Oh. Wait, what? Dwayne did it? Could you please not give me too many spoilers for the sub-levels? Wow, Dwayne did it. You love to see FPS bound stuff. If you want to know, now I've got to check. I'm playing the game at 30 frames, but I'm streaming it at 60. Now I'm curious if we choose. Yeah, my computer's not lagging, so that's probably why. How to solve maze. How do we reuse a maze again? Make this a function. Use maze. Bonk, bonk, bonk. If name is main, use maze. What about for orbs? From maze, reuse, import, reuse, maze. If you use a boost current cash again for a bed, meaning you heavily boosts unlimited upgrading. Yeah. Okay. Don't know what you've... Actually don't know that part of the game. At the moment I just want to focus on Maze. Feeling this is going to eventually break. Okay, now the maze is going to start to break. Or not? Oh. Looks like we're getting lucky so far. Can definitely optimize this. That might be a tough one for the program. Or not. Takes a while. There's too many useless moves. I still have no idea what's doing bad. This way both has broke. Okay, time to get the treasure. How much? A lot. We have a gold hat. Your reward is for gold hat. I know it's unrelated, but gold hat. Ooh, traffic current stack. Where's the gold hat? It's literally just... How do you have a whole cup? No. Whatever that is. It's not the cup, there's a name for that type of cup. Well, the maze kind of works, I just need to implement a better maze over. Improved. So we solve the maze by taking in the maze map. Tells us where to go. Current equals possession, goal equals... The mazes have a useful function. Measure, and it turns the position of a treasure. Goal equals measure. Oh, one moment. Got to let the cat in. Okay, back from Latin cutting. Let's have some music. So you have a map for current goal, for current position and goal. Oh, I need to... Okay, music. Now, the way this works, we'll say facing is north. Okay, class test. Okay, you can't have classes. That's fine, I can do it without. Facing equals north. Base map. Route equals empty path. No, root equals one of those. And it's a tiny maze. It shouldn't stack overflow. No, I need to prevent stack overflows. So Q is this. While Q dot while length of Q is greater than 0. Search equals I equals Q dot pop. Dot pop does from the back. And I can do from any element. List of pop 0. In that case, I will make it an actual queue. And you say if self, no, not if self made, if search is equal to goal, break, because then the treasure has been found. Else we just do Q dot append Q dot append. Okay. Directions is equal to maze map of the current search. So we now have a direction so drone can go. And now we do directions dot. Can we do? Can we loop through dictionaries? Yes, we can. Oh, well done. Direction for the and directions. Q dot append from move import position went too far and position offset, I guess. Position offset. Q dot append position offset search 0 search 1 direction. And finally, we want root at search. This needs to append a bit more. Score equals Q search data, and we have Q start off as current 0. So now that score is here, you say if there is not equal, it's not equal to facing score plus 10. Then we give the position and score. Else score plus equals 1. Position offset, yeah, that just returns XY. And finally solver. For maze solver improved import solve maze. For maze solver import solve maze first. Maze map. For mazes import spawn maze. Name is main. Spawn maze. Solve maze first. Solve maze map. And yeah, that looks wrong. This looks better. Let's see how much this can solve. I forgot to add in the reuse code. From maze reuse import reuse. I forgot to open more code. Oops. Import reuse maze map equals this. For now, to make sure this is working, I want to quick print the map. Okay, what is it doing now? It stops. That's weird. Oh, I put the reuse in one place. It's... Okay. I'm going to reset the maze. It seems to have broke itself. Ooh, tons of data. Okay, there's not like the key I pass in. That's a big map. I do not need to print the map. We have debug for that. Apparently we just need to convert this to pull. Okay. My tablet is doing that. Yeah. Next equals this mess. If root next continue q dot I'll deal with sub-levels when I get back to them. I've got too many other stuff to deal with first. Okay, this. Let me decide that later. I want to focus on definitely not farming first. Can you pop from a dictionary? You can pop, I'll just do pop. Because fast code BP, you can pop on a dictionary. Dictionary. Yeah, you can just pop. That's weird, but it's whatever. If Q next continue. That should avoid infinite loops. There is no part of a set. That is the next problem. Can you do the pop on? You need the key. So we're going to have to get the first key somehow. That was a set. I don't think there's a keys method. No. Back to... As much as I want to do a dictionary, a tuple is just going to be easier. for and Q, if 0 is next, continue. Harvest and resolve. Oh. 1 cannot be used as a key. Is if next in root. And looks like it's still broken. Okay. Gather from the harvest the farm. Do polyculture. I'll just add in a clear statement. Now whilst stream and chat is watching the farm, I'm going to be back in a moment. Okay, I've returned. So, for this meso to work out, I did just realize we need to store the direction as well. Can't do much without the direction being stored. Much as I like making it, it just gets messy. And direction. So root, we do not use root anywhere. Root of search, and we'll have direction. Direction equals score. That's the score we get for this cell coming in at this direction. This was much easier and worst. So directions is this, which we already have. This we can't do much about. We give it 10 if we have the turn, 1 if we don't. And if next 0, yeah, no. If next 0, next run the in root, which is this key. We continue because we don't want to redo it. And if 0 is next, 2 is direction, then we also continue. Okay. And we also need to, quick print map just in case. I will deal with a map later. I just want to get the maze set up first. That's what we need. We need from... Oh no, we already have a spawn maze. Okay, that's a maze. Did it already complete it? Debug, nope. Where's the output? Output. Okay, let's harvest and reset. Oh, I know why. I forgot to return. I forgot to return root. Harvest and reset. Okay, apparently this is root. Which is worrying because that's a really short route. How do we do debug? Okay, we can just breakpoint. Harvest and solve. So now it's getting a lot of data. Now the maze map should be gigantic. Yes. And now we do the fun debugging bit, which is not fun. So we have a direction. North. Okay, this is 2-2. Yes. So let's go and we need to go north. We haven't found it. So we set it to score of 0. Because it's this cell. The directions should just be north. For the... Okay. For str, the equals direct. No, as that said, we don't need to have these. We can just make phaser keys, which looks weird in my opinion. If it's allowed, it's allowed. Now that we've got those, there is a direction. Hello, Isaac. If directions if not, continue. Fine, have your code block, new line. Oh. Ooh. Did this... That's not good. Okay, I'm going to need to open the output. There's too much output. I don't think... Yeah. Stream can't see the output. was worrying if this output looks good. Okay. This is worrying. Well, we'll just create the last. Please go to. No, I want to keep it separate. Now we just go to have last function as maze follow. This will be maze global solver. Define the follow path. Direction equals north. Position equals position. From move input position. While true. Options is path. What's output again? Okay, path. Position 0. Position 1. Direction. So north. Okay, that's only 1770. If there's only 177, but there's like 76 and 76 north and south. Mazes get really complex. I don't think this would work. Direction. Okay, no, this is. LA. Okay, a Q can still be this. How do I follow the maze again? I think I'm storing the data incorrectly. Yeah, I'm storing it too early. It needs to be here where we store it, I think. Harvest and break. 77 is not a key. Why is a map? Okay. No, the map is just... the map is just broken. Okay, now it's processing. It has a whole maze. Let's see. We are currently square 47. This needs to be there, I think, instead. Might be lucky. There's one problem with our algorithm. It kind of needs to search the whole maze. Something might have broke. If the numbers just keep going up, something broke. Oops. Okay, reset the maze and try again. Good, it's got the whole maze to search through. I broke it. I have definitely broken it. As much as they should be easy, but they're always hard to implement for some reason. Okay, one moment. I'm going to bring up my Rust code. Because I've done this in Rust recently. I just have to remember which day it was. Please just give me a moment. No, that's not the day, that's a different day. It's close, but it's not what I need. Might have found it. No, that's a different day. I found it. Okay, just have to translate Rust code into Python code. If I can remember what this Rust code was doing, because Rust is completely different. Fast time. Okay, fast time. We've got time. Well, we have a map of every single cell. So it's not the exact same map. Of it's a weird. I'll just rewrite the code. Dev Mesover 2 map start goal. Facing is north because that's easiest. Then we have search, which is an array, and the first item is going to be path of start, path of start, direction of facing, score of 0, then rounds length of search greater than 0, it equals search dot pop 0, and yes, there's also the positions dictionary. Which is this. Did I use? Okay, I did use that. Oh, I see. Okay. Previous is another dictionary of pause. And -1 north, and finally a score of 0. So if positions data search the pop the past data dot da data dot pass if this in positions continue. We don't care about that cell because we've already been there. Now valid equals the map of data pause 0 data pause 1. So for directions for the invalid. If valid, if not valid, the continue. Don't care about the invalid ones. Next path is equal to from move import session offset. Session offset this data as position offset and it takes in the direction. Let me just check code to see if it's doing what I think it's doing. Yeah. Oops. Direction. That's already fine. If next path equals previous path, continue. And then if position, if key, okay, if next pause the in positions, continue. Hopefully it doesn't get added back into the queue. Then we have score equals, what does this function say? Get score from rotation. Okay. Shouldn't be any code here. Oh, I forgot the bracket here. I will do it in here. Def, rotation, score. Rotation. Original and new rotation. If original is equal to north, if new is equal to north, return 1. New is equal to east, return 1001. New is equal to south, return 2001. New is equal to west, return 1001. Copy if org is east, if org is south, and finally if org is west. I'm just going to separate this out to a new file. Hidden score. Just because it's kind of long. From rotation score, import rotation score. Score equals rotation score. Data. Da. And I need to change all the fees. One, and finally 1, 2, 1, 2, 1, 0. So now that we have a score, we need to do search.append pass of next pass, there, of there, and score of score. And finally previous only cares about the position. So we have previous be 0, 0. Pretty sure, yeah, previous only cares about the position. And that should be a better grid. Return positions. Oh man, what is this do? Do we insert? Nope, I forgot to insert it. Positions dot append. Positions. Data of type pass. Data of type da. Equals data of type score. Maze over 2. Maze over 2. From this, import this. It takes 3 arguments, yes. Position and goal. And measure. From move, import position. Harvest and win. That takes 3. How many are you being given? Incorrect amount. I'm just going to add a clear to this. Three-7 rest cannot be used as a key. What do you mean it can't be used as a key? Oh, is it? Okay, next plus 0, next plus 1. No, wrong function, this one. Yes, it's just technicalities. Doesn't like the wrong data types. That was too quick. Why did I not append anything to the queue? What? Six, okay. Six zero east cannot be used as a key. Indeed, it cannot. And go again. Key 6-5 is not in the dictionary. That's interesting. Okay, that's just... Gonna have to fix that. What the... I'm going to have to fix these weird edge cases at some point. Got to get it to scan the whole maze. Fish is not... Got to get lucky on the maze spawn. Okay, this will do. It got me a list of numbers. Someone forgot the plus. Oops. Nope. Stop. Ah, this is a good one. Never mind, it's broken. That's wrong plus. Score is data of score plus rotation score. Ah, was out too quickly. Should probably get it to scan the whole maze. Can't be bothered too firm. Oh, that seems like a good one. What works? 00 is not in my dictionary. No, 07 is not in my dictionary. I thought you went down there though. Okay. Yeah, it works with a gigantic output. Yeah. Okay, that seems not fun to do. And because it's getting late-ish, we're going to stop dealing with mazes. And what to do? Do I make snake or do I make chess? I have worked out how to do both. That's a polyculture. Let's just move mazes out of the way for the time being. Because first off, we need to increase the size of the farm. Didn't want to do this too early, but now we have big farm. After here. Okay, now I can make smaller farm. Oh, we do have access to those. Don't need drones for chess. Whilst I'm here, just upgrade everything else. Chess or snake? Well, because I have most of snake already here, I probably could just continue with snake. But chess seems fun. Let's make chess. Chess seems more fun. So, you have the pieces. Okay, this is the chess data. So the pieces we need are for rook. Rook, which is going to be... What should rook be? How does plant work again? Plant. Entities. Entities dot. Let's have it be a tree. Rook is a tree. A bishop is a sunflower. No, the queen should be the sunflower. The bishop can be some carrots. The pawn is the grass. As the king is edge, with a knight being a pumpkin, I guess. Okay, now I have the pieces. Now we can start in chess. Spawn board. Clipboard. Play the music. Okay. Clear the field. Then I'm just going to white this manually. Because I don't know how to do it. Otherwise, from chess data, import rook, bishop, queen, pawn, king, knight. Plant a rook. Move east. Plant. What goes up with rook? I think it's the knight. Yeah, let me just check. Chessboard, yes, it's the knight. Plant, knight. Move east, plant. Move east, plant. Bishop. Move east, plant. Now which way is the king and queen? Oh, the kings are... Okay, the king is on the white. Plant queen, plant... Move east. Plant king. I need to just tell everything. till plant on move rest. Let me just give this a quick test. Spawn board. Yes, for pumpkins. We're missing the king. Why do we not have a king? What's a king? Is bush, not edge. It looks red, but there's a chessboard. For I in range. It's an 8x8, so 1, 2, 2, 4, 6, 8, yes, so 2. I in range 2 for I in range 8. Till move east. Move north. Copy, paste. Move rest. Oops. Move north. Shrink this down for now. Oh, this is meant to be 7. No, it needs to be 8. Oh, the move needs to... we'll just move east. Just doing the lazy method for now, I can improve it later. Move west. Move north. Move east. And now we just need to do the rest, which is till, okay, for I in range 8, till plant born move east, move west, move north. And we'll also use items.water. No, never mind, we can't water. No, never mind, we do water. Yes, never mind, never mind. They should have 7 rows done. We'll use the water 3 times. Now we plant a rook east. know is a knight. And his rest. Plant. Plant the bishop. Have government rest. Water. Plant the king. Plant the queen. Plant another bishop. Plant a knight. And finally plant a rook. And then we'll move to C11. We have too much water. I forgot to tell. Oops. Till and till and till. Till and till and till. Just like that, a chessboard. Oh, dead pumpkin. Okay, first watered more than I thought. Whatever. The point of water is to tell their black pieces. Yes, it's a messy function, but we don't talk about this chess spawn board function for now. We will actually get to implement in chess. But before we do, we need to save data. Worked out how to store the position of each of the pieces. We only need to store the position of the black pieces. The white pieces we can just get off the board itself. So we're going to say problem is in order to store the in order to store positions, I've made this whole document. We do not have cactuses. Can we unlock cactuses? No, we can't. I'm going to go and unlock cactus. Where's the cactus farm? Sorry, the pumpkin farm. Where's the clear command? Here it is. How many pumpkins is this going to give? So normal is 16 and 28. Oh, forgot to do that. 432. There's a lot of dead pumpkins. Now I've got to make it. Now I've got to watch it make a gigantic pumpkin. Yeah, I am disabling the flip for next round. Ooh. 3.45k, that's enough. Oh. Can't make a gigantic pumpkin. How big can pumpkins get anyway? N by N. Even when this pumpkin is... Okay. That's annoying. Well, we have the pumpkins we need. We have cactuses, which also seem complex. But we're not here for cactuses, we're here for chess. It's just cactuses are required to save data. Now that we can store decimal numbers, we can do some fun stuff. Okay, first off, we do need a dictionary. Data, 0 equals A. Will you get annoyed? Yeah. Store this. 0 is okay. Where's this file? Oops. No mean to attach it unfair. I worked this out a while ago. I wanted to work it out. I worked it out earlier this week just so I could work out how to do other things. 2, 3. Can we have a I don't think you're allowed to do this. It will. Interesting. Keep getting treasure. Can't really plant treasure. Entity start. Sunflower. I missed the bush. Five, 6, 7, 8. Finally. Cactus. Missing comma. Okay, now that we have a data, we can write some numbers. Store data num. So, well, do we have some operations? Do we have div and mod? We do have div and mod. Dev div mod xy return x div y x mod y. While num is greater than 10, em is equal to the div mod x by 10, num equals em 0. Then we plant. Well, we need a dev plant data index. So type, yeah, type's good enough. Stored index. If get ground type is not equal to type 0 tib, and if type 1 is equal to none, harvest. Type 1, otherwise we just plant type 1. Plant data num. So we'll first move to 0. Get world site. get world size -1. Plant data DM1. And then move east if x equals 0. X equals 0, move to x. If get plus, no, this is meant to be y. Get road size y. If this equals 0, y plus equals 1. Move south. Now we just get data. Only downside to this is we can only store one number, so we're going to have to be creative in how we store numbers. But we have binary, so it should be fine. Move to 0. No, you do want to start at... Okay, this needs to be get world size -1. And y we de-increment. And we build up the number in reverse. Oh, and at the end we plant a pumpkin. Because that shouldn't break anything. Hopefully. So the count is 0, while get entity type is not equal to pumpkin. We need to def data plant. And then for I installed because lazy. If get ground type equals stored I0 and get entity type stored I1 return I. Sum equals 0. No, data plant num equals data plant, sum equals num times 10 to the power of count. And 10 to the power of 0 is 1. And return get data. As a test, if we store data, every single number, print get data should return the same thing. Oh, that's a power operator. Okay, one operator. Uh-oh. Oh, I forgot to import move. From move, import move to. Store data num. Okay, that's not a good sign. Why are you erroring? The one argument of plan was none. Oh, I forgot to return. Okay, we will set 10 to ground.soil entity.pumpkin. Plant data 10. Just to make sure everything works, click clear. I forgot to say to move east. If get plus x is equal to 0, y plus equals 1. No, negative equals 1. Num is data plant. We turned 0. Oh, I return. It's meant to return some. You are not meant to be a breakpoint. 2. I think this is more than 2. Zero 9 8 7 6 5 4 3 2 1 2. It's meant to move east. Oh, well, num is greater than. Greater than 0. Zero. Sum plus num times 10 to the power of count. Getting there. We'll just debug and print num. Nine, 8. Okay. It can definitely count it correctly, it's just not returning it correctly. Eight, 70. Nope, that's not right. Hmm. Hmm. I forgot. Count plus equals 1. Nine 90, 890. Good. So if we get rid of a print, they should return the correct number. And it will always return that number. Let's see, if we expand it again, will it still return the correct number? No? I forgot move south. If this works, I can create the logic. 6 and a couple of zeros. That could just be Python. How big is the number? Thousand, million, billion, trillion, quadrillion. Yeah, that's cool. It's a 64-bit integer limit. If we put in this number, it should work fine. Yeah, close enough. Now we can ignore the data and make chess. So the data is important because now we can store the location of the black pieces. So how do we store the piece locations? Well, for piece location we can already store where it is. So we just need to store which squares are black. And for black square, store black XY. Can we just use X by Y? Don't think we can. We have 60. We have 59 bits to play around with. It's a 64. Whatever number we make is going to be one number. So how do we store everything into one big number? We can store 64 bits, but I'm not sure how secure that how recoverable that would be. What happens if we store 62 bits? No, 63 bits. It's a dead pumpkin. A dead pumpkin is still a pumpkin. Or get entity type goes entity start dead pumpkin. Yeah, we lose the precision. And the precision is key. Wait, why are we even adding this? Ooh, out, that was a lot of precision lost. Why are we even adding this? We don't need to give this a sum, we just need to give this an array. Sum.append num. Name or count. And no more dev mod requirements either. Because we just send an array of data. And nums for num in nums plant num that should do. One, two, three, four, five, six, seven, eight, nine, 2, 2, 5, 1, 0, 2, 6. Now we can store a ton more data. Right, there are only 16 pieces. There are only 16 black pieces at any given time. Which means we only need to store 32 bits of data. Still black squares. X in range 7 and 8. For Y, for X in range 8. Black equals this. If get water is greater than 0, black dot append X. Black dot append Y. Store data black. From data import store data get data. Def get black squares. Get data. For num in range loops range okay. In range get data. Små fandfærdige And with this, not good. Too much data. What to fix the data issue? Why is it storing too much data? Get what is greater than 0. All of these like... No, why do you have too much data? Okay, scans all the squares. Black has way too much data. That's like every single cell. Is it not get water? No, it is get water. Huh? Print get water. I just want to spawn a chessboard. Once we've spawned the chessboard, that's pretty much it. Ooh, the logic's done. Pring. Okay, let's see. 0, 0. Is that just a... Is that just a bug? That might be a bug, and not one I can fix. Because as you can see, X and Y, these two lines are being cooled, but they're not meant to be cooled. So I'm just going to assume that's a bug and work around it for now. And then I have to make a lot, that's not going to be fun. Yeah, now I've offset it by small bit is happy. Okay, I'm just going to assume that's a bug in the simulation. One I can't do much about. Is it... Probably should be saving more often. Oh well. I have to report it later probably. Okay, let's see. Moment of truth. This is already looking much better. 24, 36, 35, 34, 33, 32. 32 pieces of data stored. Which means we can actually start to move pieces now. Which is not going to be the fun part. Because the logic to move a piece is simple. The UI is not simple. It's chess, pawn, move 1. And then we're going to have stuff like chess, pawn, move 2. And then I guess even more complex, like chess, pawn, not chess, pawn, rook, move 1 north. Apparently there's a file limit. Okay, 1 north. To move a piece is easiest. Chess move. Chess move. Just call it M, but all we need is piece and direction and squares. Oh, actually, we can simplify the UI. All we need is move chess square 1. And then we can have chess square 2 and chess square 3. Anyway, move piece. Color piece direction squares. Now this is going to be the not fun bit. This is the one function we need to write. So there's too many things to worry about here. We have like the white bishop and the black bishop. Same goes for the knights. Oh, the knights can change color of squares. That's not fun. I can't just say like knight 1 and knight 2. I've only got limited amount of data. Okay. Considering how late it is, I'll get the pawns moving for now. But and then we can worry about the other pieces another time. Goes forward if as much as I say I want to get the pawns moving, I don't know which piece I'm referencing. We can get the piece type from the position, and I think that's all we need. So we'll get the piece type from position. Then we'll have entity to piece. Entity, and we'll just say if entity is equal to rook, return rook. If entity is equal to bishop, return bishop. If entity is equal to queen, entity equal to pawn, return pawn. If entity is equal to king, return king. If entity is equal to knight, return knight. Position, so piece equals entity to piece get entity type. Move to position 0, position 1. From chess data import entity to piece. From move import move to. Pawns can go diagonally, so we'll keep. So we have to do that. If piece is pawn, direction is forward. If color is equal to black and position 1 is equal to 6. Okay, so move 2 is equal to this, or color is equal to white. I know. And position 1 is equal to 1. And then we'll just say if squares. Do we have a clamp function? Probably not. Can clear to get cost, get surface land list, max measurement move. We have clamp. Well, no, we don't have clamp, but we can make our own clamp. Max return is the minimum of the maximum of the max fee min fee, I think. No, it's min fee max fee. Yes. Okay. And then count equals clamp squares 0 move 2 equals 1 if this move 2 equals 2 move 2 and then to finish it all off we harvest, we move to position 0 y goal equals position y goal equals 0 if color is black, white gold is... I'm going to have to tidy this up next week. If color is black, white gold equals position 1 minus count. Else, white gold equals position 1 plus count. White gold and plant. What entities the piece? Pawn, king, queen, bishop, rook, knight. Plant a pawn. So, in theory, from chess move, import M. White moves pawn. I know the terminology, I just haven't translated it. Let's say we move 3-1 forward by 2. And if we try to do it again, well, it fails. There's not a pawn there. If we move this to 5-1, okay, 5-3, nice. It's curved. You can... It's... It's totally curved. But you can... move your pawns around. I just need to do... a bit more logic, and if we test for 1, that also works. So the final thing I want to do is from black logic import rewater squares, store black squares. And you also need to import get black squares. No, we'll just import store black squares. So before we do anything, we need to rewater squares. That's important. And finally, we need to store black squares. And we're going to simplify this a bit by saying positions 1 minus count. Position 1 minus count. And after E of the this, we'll use items.water. And whilst I remember, I've already set this to 0.01 earlier, 0.5 is probably a better idea. So now, if we reset the grid, we should be able to move a black piece forward 1 square and store the data. Water level really doesn't go down that quickly, huh? That might be an issue. Okay, it says reading the data. It's rewatering the same square. And I moved it forward. And now it's trying to store this mess. Oops. I forgot the move to square 0, square 1. Now I need to respawn the chessboard. Uh, 0.5. Ooh. Okay, we're going to say 0.6. Because otherwise these 0. These are just going to take forever to go down. What are you trying to do? Okay. I messed up. And now if we move a piece, it recalculates every square to get the water levels. It moved one piece. I know you're broken because you moved one piece. Oh, it's because rewater squares comes after. Okay, we'll just have another move to at the end there. Really need to get the sunflower system working again, so we can make it run go speed. Also, I think we can probably just increase this over to 0.8. Because rewatering phase 49 was outside the bounds of list. Huh? Oh, it's not recognizing a dead pumpkin. I thought I fixed that. And okay, now it should be fixed. Yes, it's fixed now. Does it go down in time? No, it does not. It's a really hard balancing struggle. I've got an idea. Sleep for 5 seconds. And move a piece next door So it's going to think there's another piece there, which is fine. Wait, we don't have a sleep function? I thought we had a sleep function. Swap direction? What's this? Interesting. Oh, it's for cactuses. Okay, makes sense. We do not have a sleep function. Or a wait function. Do we really not have a wait? No, we do not. Do we really not? Okay. T equals get time. Wow. Well, get time minus T is less than 5. Continue. Yeah, let's respawn with chessboard. Just got to let it read the data. So quick at reading data compared to writing data. And move. There should be a perfect test condition. Feels like you waited long enough. That's still way too light. Okay. I'm just going to write a comment for myself. After moving a piece, just update it manually in database rather than refresh everything. And with that, I'm going to call it here for today. If I want to finish writing chess, it's probably going to take me another 2 hours or so, and it's getting quite late. I really underestimate how long it takes for me to write code. But I could get 3 games done this stream. Apparently not. So yeah, next time we will be actually hopefully finishing chess. Getting it into working state. Off camera, what I might just do is this whole UI, because typing out however many files is just going to be a pain. But for now, we go back to polyculture, which takes a while to get set up. Yes, I've tried and it's possible. I know it's possible, I just have to spend a lot of time. So this is going to have to be a multi-stream thing. Well. Oh. And there's the end of the soundtrack I kind of have. thank you for coming. I don't have much else to say really. I kind of failed to do what I wanted to do. So I guess just watch the farm, do farm things for a while before the stream ends. And see you next week hopefully, if I'm not too busy. Shouldn't be.